It's 1:02 p.m. on Thursday, the 28th of June, 2012. I'm Mark Strassman. I'm a partner at Green Asset Finance. I'm about to talk today with Greg Springer, who's the president of Green Fuels America. He's based in Sparks, Nevada, not far from Reno. Welcome to this conversation.
Thanks, Mark.
I want to urge our viewers to use the full screen capability of their viewer in order to be able to read the text of the slides that you're going to use to help explain some of the answers to questions that I'm going to ask you. So I just wanted to make that note.
Very good.
Okay, why don't we start by telling our listeners what a biofuel is?
Well, a biofuel is a renewable source that is grown, and in some cases it's an animal, so it could be animal fats, but it could be algae. Quite often it's an oil seed or some sort of plant like coconut or palm.
Okay, and what is biodiesel?
Biodiesel is a diesel replacement that is made from one of these renewable sources. It mimics petroleum diesel number 2 in its performance, but it has 85% less greenhouse gas, so it's much better for the environment. So 85% less CO2 emission. It's typically biodegradable, and those are probably the two main characteristics of biodiesel. It does everything that regular petroleum diesel does, no modifications to the engine of your car.
All right. Tell us what we mean by a feedstock.
A feedstock in terms of biodiesel is a triglyceride. We'll talk about that a little bit later, but in this case, again, it's the material oil that we make the biodiesel from. It's could be soybean oil, palm oil, coconut oil, used French fry oil, animal tallow, even in some cases algae.
Okay, give us a general overview of the steps of the chemical process by which a feedstock that we've just listed is transformed into biodiesel in the FuelMatic system that your company manufactures and sells.
Okay, I'm going to switch over to some slides here.
Okay.
Let's take a second to bring it up. Bear with me.
Okay.
Okay. And we should have it right here shortly.
It says feedstock flexibility.
Right. So, again, to answer that question before, use cooking oil, oilseed, animal fats, and these are some examples. The process, oops, I've got to press this button here to get the slide to change. The process really has 5 steps. First, we bring the feedstock into our machine. And the second step is we take the feedstock which is brought in and we add methanol and methylate. And I'll explain what we do with those in a second. Let's think of a triglyceride, which is the feedstock, as a molecule which has 3 long hydrocarbon chains hanging off it. These chains may be anywhere from 12 to 24 carbons long. And what happens is the methylate is a caustic, and its job is to remove or separate the hydrocarbon chains from the big glycerin molecule. So the caustic separates that, and then the methanol we plug onto the end of each one of those hydrocarbon chains. That creates what's called a methyl ester, or in this case, biodiesel. The next step is we need to get the biodiesel, which is now the combination of the hydrocarbon chains and the methanol, separate from the big glycerin molecules. That's done, it's called glycerol separation, and in our process it's done using a patent-pending process that uses gravity and sort of a suction to separate those molecules. Now, when the oil is brought into the system, the feedstock is brought into the system, and even methanol and methylate, they all have some percentage of water. in them. It may be 0.05%, but there's still a little teeny bit of water. When the water sees that methylate, which is the caustic, it makes soap. And that soap dissolves into the biodiesel, and we have to get it out of the biodiesel before we can use it in a vehicle. Otherwise, it creates what's called coking. And so we have an ion exchange resin called amberlite that's made by Dow Chemical, and the biodiesel falls through that, and the soap, which is dissolved in the biodiesel, has a propensity now to go into the resin, and the biodiesel comes out the bottom of that column is cleaned. In the process, we said we were adding methanol to these carbon chains. We actually put in more methanol than we actually have chains for those methanols to find. That's called extra stoichiometry. And what that means is there's also extra methanol in the biodiesel that is made, because the methanols found all the hydrocarbon chains, but there's some extra methanols. So we have to remove those from the system, and that is done by a flash evaporation process. And after we remove the soap, then we remove the methanol, and the biodiesel is then clear and ready to be used in the next step of the process, which is transesterification. So this is the chemical diagram here, which explains what I just tried to explain verbally. The triglyceride is on the left, and that is the glycerin molecule, and the R1, R2, and R3 are the hydrocarbon chains. You see we have 3 methanols because we have 3 hydrocarbon chains on each one of the triglycerides. The catalyst is the caustic. Its job is knocking those hydrocarbon chains off. And if you look to the right side of the equation, what you see is the free glycerol, and now 3 separate fatty acid methyl esters, aka biodiesel. But those are the roles of methanol and methylate in the process. This is a picture of the actual 5,000 gallon a day FuelMatic biodiesel processor, which does these process steps that we've just spoken about. The oil comes in on the very far side where it says oil fill pump. Well, those flanges there at the very far right is where the biggest one is where the oil goes in, and the smaller ones are where the methanol and methylate go in, and then the one on the bottom is where the glycerol from after the separation comes out. And really, what happens is that you see there's a oil preheat vessel on the far right there. We bring the oil in there, we heat it up. The reason why we heat it up is the chemical process goes faster if it's heated. So we heat it up, and then we bring the 3 elements that we talked about, the feedstock, oil, the methanol, and the methylate, into these 2 reaction vessels, which are reciprocating AB. So one is filling while the other one is emptying, and the other one is emptying while the other one is filling. The actual transesterification process that we just showed in the chemical equation happens in those 2 chambers. And behind it, which you can't see very well, is the glycerol separation device, which separates the glycerin from the thane. From there, it's pumped into the large amberlite buffer tank, which is on the left side of the screen. Again, what we're doing is we're heating that up, and we're flashing off methanol in that. And behind it are the amberlite purification columns, where we remove the soap. And once the soap is removed, there's one more, you can't really see it, but it's at the bottom it says methanol recovery vessel. We flash the biodiesel into there at a temperature high enough that the methanol boils and turns into a vapor. We capture the vapor and condense it back into liquid methanol and reuse that back in the process chambers that we showed earlier. So that's a pretty good overview of how the process is done.
Okay, that's great. How much biodiesel do you get from a given amount of feedstock?
From 1 gallon of feedstock, we get essentially 1 gallon of biodiesel. So it's a 1-to-1 conversion. The methanol and the methylate, that weight turns into the same weight as the glycerol that comes out the side. But as far as feedstock to biodiesel, it's a 1-to-1 conversion.
Okay. And how much biodiesel can the FuelMatic produce in a day?
This particular one, the FuelMatic, is 5,000 gallons a day, which is 1.6 million gallons a year. We also have a smaller one at 2,000 gallons a day and a larger one at 12,500 gallons a day.
Okay. What are the advantages of using a community-sized system like the FuelMatic for biodiesel production?
Well, if we look here at this slide, we talk about community scale production as being putting our machine near the source of the feedstock. So that might be in population centers, that may be a grease collector, in a town or a city. In agriculture communities, that may be out in the palm plantation, that may be in a coconut field, that may be in the soybean field. In the tropics, it's palm and jatropha. It could be out in the middle of Argentina where they grow cattle. And so what we're doing there is getting animal fats and rendering. So we put the machine near the source of the feedstock, so we get rid of all the costs of moving things around, which is a large expenditure. And hopefully the end biodiesel can be also used in the local environment, in the farm tractors and the trucks and all of the equipments associated with the moving the materials around. Also associated with community scale production is, again, this regional energy independence. We have units in Paraguay that are up the river, long ways from power plants and long ways from lots of things. But that particular region, the cost of fuel is very, very high. Making the biodiesel locally and using it locally saves them considerable amounts of money. There are also government economic programs. For instance, in Colombia, they've mandated that I believe they're at 8% right now of all diesel sold in the country will have 8% of biodiesel in it. And again, this lower cost of logistics of moving feedstocks and biodiesel around, and as opposed to bringing in petroleum diesel to some of these countries that don't have a pipeline infrastructure.
So it's green logistically as well as biochemically.
That's correct. Of course, because again, when you use the biodiesel, you're already 85% less greenhouse gas. And of course, you're using up those feedstocks that might have been a waste material and a pollutant. But now we're making some biodiesel from it. So there's a number of ways that biodiesel is very green.
Talk about the trends in global demand for biodiesel.
Did I make a slide?
It says drivers for biodiesel production, yes.
Well, as I said, in the upper right-hand corner is government incentives through tax breaks. For instance, in the United States, we have what's called the Renewable Fuel Standard 2, which is administered by the EPA. It says that any greenhouse gas producer of more than 25,000 tons per year per facility is called an obligated party. Those people who make renewable fuels like ethanol, biodiesel, synthetic fuels, biomass, all these sorts of things, get a credit called a RIN when they produce the renewable fuel. And as it gets mixed in or used, in the case of biodiesel, when it gets blended into a B5 or a B20, which means 5% biodiesel or 20% biodiesel, then a tax credit is sellable to those obligated parties to offset their carbon pollution. So that's, in the United States, a huge driver. Going down the left side, we've talked about regional independence and lower cost fuel, lower CO2 emissions, creating businesses around local feedstocks. In the case of Spicewind Pacific Group, they have coconuts in the Marshall Islands, and they have fields and fields and fields of these things that just fall on the ground and some percentage of them was used, but in our case, we'll use a lot more of them to make biodiesel in this local environment, which has only imported diesel, which is very expensive. Supply of biodiesel government mandates. I talked about Colombia, and in fact, there are over 50 countries around the world that have government mandates. Recycling of waste grease. I mentioned that a lot of cities at Thanksgiving clog up their wastewater systems with grease because people are dumping turkey grease down the drain. In this case, the reused grease can be used to make biodiesel. There are government incentives on equipment. South Africa is like 30% of the cost of equipment to build one of these facilities will be paid for by the government. So there are a number of fuel cost reductions for fleets, carbon credits in the UK and Europe and Japan and all the other Kyoto countries. So there's quite a number of drivers for the production of this biodiesel to use waste fuels and to have this 85% less greenhouse gas.
Okay. How much does the FuelMatic cost?
The FuelMatic, the 5,000 gallon a day, is $640,000, which includes these things here on this picture. It's shipped in a sea container. It includes the supervision of the connection to the facility, the power and the piping and the air manifold and the operator training, and then the first production of biodiesel.
Okay. And tell us a little bit more, if you can, about the Spicewind Pacific Group's plans to use the FuelMatic to produce biodiesel from coconuts in the Republic of the Marshall Islands.
Absolutely. First, I'll give you a quick commercial on green fuels here on this last slide.
Okay.
These machines that are shipped around the world, we have currently 25 of them on 6 continents. And as I've said, our mission is to provide these small community scale machines to be located, near the source of the feedstock to produce a decentralized approach. So let me see if there's any other pictures. For instance, here's a picture of one in Chiapas, Mexico, and let's get my video back live for you here, and then we can answer your question. Let me see how to do this. Stop sharing. And we need to. The microphone off by mistake. Okay. So to answer your question, Spicewind Pacific Group is put together a business plan that will use a FuelMatic biodiesel processor in the Marshall Islands and coconut as the feedstock. So the coconut will be crushed, the oil will be extracted. There'll be some preconditioning, but primarily go straight into the FuelMatic. We will make biodiesel right there in the Marshall Islands, very near the docks. The offtake clients will be the local island, of course, but also they will sell them to tuna fleets and other commercial fishing and other commercial freight vessels. Biodiesel can run in diesel engines like a diesel marine Caterpillar, just as well as in a diesel engine. So often they will also use them to run Caterpillars with a generator on them to create electricity. And so in this particular case, they have more than enough coconut plantations to provide the feedstock for the 5,000 gallons a day.
Is there also a market there from the military that as it repositions itself into the Western Pacific?
Yes, there is a contract with the U.S. U.S. Navy that is available, and they're very interested in this because the U.S. Navy is already the world's #1 user of biodiesel. Most people don't know that, but in the United States, the #1 user of biodiesel is the U.S. Navy, obviously, if they're #1 in the world. So they've been running biodiesel in their fleet for, I don't know, 8 or 10 years now. And so, yes, they're quite interested in not having to import as much fuel into those islands than they have to now. Right now, there's only one producer. I can't remember who it is. I can't remember if it's ConocoPhillips or somebody else. But there's only one person who imports oil in there right now, and the market price is over $10 a gallon.
Okay. Why don't you wrap up by telling us what your major satisfactions are from being involved in this kind of work?
Well, the greatest thing about what our company does is we're able to do these community scale things, and I said we're on 6 continents. These include Australia, and we're doing jachofra plantations in China, and Paraguay chicken fat in the middle of nowhere, and Tapachula, Mexico. There's a great story. I'll tell you about that plant. The city, the state of Chiapas, Mexico, bought this thing in combination with a 7-country group that was doing studies on biodiesel, and they bought machines from 3 different companies. It turns out ours was the only one that worked. But what they do is they hire their local impoverished people. They give them about an acre of land, and they either cut palm or they pick jachofra, and they put it out on the cart, and the state truck comes by, picks up the whatever it is, the palm oil or the jachofra beans, whatever, and they crush it, and they run it in our biodiesel plant, and then the biodiesel that comes from that they use in the city and state vehicles. And it's actually quite famous plant in Mexico. It's really the leading biodiesel plant in Mexico. The president of Mexico, the president of Colombia, a lot of dignitaries have been by to see the plants. And those are the things that really turn me on when I can say that there's a section in Mexico that it's a good quarter of the state which gets a lot of economic benefit from being green, from using these renewable sources, from being able to raise some of these impoverished farmers or tenant farmers from nothing up to a higher standard of living because they get paid by the state for collecting that feedstock. So and of course the 85% that's greenhouse gas. All those things are very much positive.
Okay, good. Well, I want to thank you very much for your work and for talking to us about it today.
My pleasure.